Hello everyone, welcome to another video. Today I want to show you something I've been working on in my day job this week, and that's the internal load balancer in AKS. So the plan for today is that I want to quickly recap the services we have in Kubernetes. Then I want to show you how we can access our service from another service, for example from a VM, from within the same VNet as our AKS cluster is. Then we're going to create a private endpoint so we can attach this private endpoint to a different VNet. And in the end, we're going to test the access. So let's first talk about the service types we have in Kubernetes. The first one is the load balancer type. And this type enables us to have access from outside the cluster. In Azure, our service gets a public IP address, and this means we can access our service over the internet. The opposite of this would be cluster IP, and this gives us an internal IP. This means only from within the cluster we can access our service. Then there are two other types, node port and external name. They're not very often used, so therefore we are going to ignore them for now. And now we talk about the internal load balancer. With the internal load balancer, we can access our AKS service over a private connection. And this is for a service that's running outside our cluster. For example, a VM can access over a private connection our service inside the AKS cluster. So this can be done either from within the same VNet. For example, if the VM is in the same VNet as our AKS cluster. And in this case, it would like this. So we have our AKS cluster and our service inside the cluster, obviously. Then we're going to create a private link service. And this private link service enables us to link our service to the VNet. In this case, the AKS VNet. And then we're also going to have a virtual machine in the same VNet, and therefore the virtual machine is going to be able to access the service inside the cluster. This makes sense if you have some application running on the VM, or applications that can't run inside the cluster, but you still want to have a private connection to access everything inside the cluster. Another option would be to access your service from a VNet that's not the same as the AKS VNet. There you have two options. Either you can do VNet peering. This means you connect the two VNets so they can communicate with each other. Or what we're going to look at today is we can create a private endpoint for our service. And then we can attach this private endpoint to another VNet. And with this approach, our private endpoint gets an IP address of this VNet, and so the VM can also communicate over the private IP. This is going to look like this. It's very similar, except that we're also going to have this private endpoint, and this private endpoint is attached to the different VNet. And this VNet also contains the virtual machine. And with this in place, one last thing I want to talk about is the documentation. There is a documentation, but it's not great. For the internal load balancer, I'm going to show you how to configure it. That's going to be with annotations, and the documentation offers several options which you can add as annotation, but it doesn't provide any explanation. And I've also found open GitHub issues that are open for a couple of years where people ask for explanations, what these annotations do, how to use them, and they never got answered. So today I'm just going to show you how I got it to work. Now let's switch over to the terminal and get started with the implementation. Here in the terminal, first define a couple of variables. That's the name of our resource group, the name of our AKS cluster, and a location. Then we're going to create the resource group, which will contain all the resources we are creating today. And then we're going to create the AKS cluster. Here I'm using the most basic option. So I just say easy AKS create, provide the resource group name and the name for the AKS cluster, and I leave all the other options as they are. Creating the cluster should only take a couple minutes, and after the cluster is created, we can deploy our application and get started with the more interesting implementation. The cluster is created. Now let's download the config file. And with this in place, we can get started with the more interesting parts. So what I'm going to do is now create a new namespace, because I like to have everything I do in its own namespace, so I can just delete the namespace when I'm done. Then I set the config to the current namespace, so I don't have to type it with every command. And then we're going to deploy the deployment and a service. Before I do this, let's deploy it first. And then we're going to take a look at two files. So we're going to apply the deployment YAML and the service external YAML. As always, there will be a link to the GitHub where you can find all the documents, all the files I'm using in the description of the video. So you don't have to type anything, you will find everything there. While the services are being created, let's take a look at the two files we just deployed. They are as simple as they can be. So we have here a deployment for Nginx. That's just a very basic container so that we have something running, and it's running on port 80. And we also deployed the service external, and that's a service of type load balancer. This means we should get a public IP address from Azure and we can access it over the internet. Let's switch back to the terminal and we see if everything has been created and is running. Here we can see it's maybe a bit hard to read, but we have here our load balancer and we have the external IP address. This means we can access our Nginx application or pod from the internet. And to test this, let's do a curl with this IP address. There you can see status code is 200, and here you can see welcome to Nginx. So everything worked as expected. But right now we have a public IP address, and our goal is to have everything internal, so it's not available from the internet. To do this, let's apply another file, this time the service internal.yaml file. And while this is being deployed, let's take a look at this file. Here you can see it's basically the same except this annotation. And this annotation we say Azure Load Balancer internal equals true. This means we want to use an internal load balancer. The result of this annotation is that instead of a public IP address that's accessible from the internet, we get an IP address from the VNet of our AKS cluster. This means that our service will be accessible from within the VNet. Now let's take a look if the IP actually has changed. And there you can see it's still the same IP address. So I have experienced that if you have already a public IP, then the IP is not changed. So the solution for this is we delete the service and then we recreate it. So we do a kubectl delete service and copy the name of our service. This should only take a couple seconds. And after the service is deleted, we're going to deploy the internal service again. With the service deleted, we can reapply our service internal YAML file. This should take a couple seconds now for the IP address to be assigned. So let's wait a couple seconds and then we're going to check our service and we should see the IP address there. So let's check. There you can see it's still pending. In my experience, it takes around 30 seconds for the IP address to be assigned. So let's check again if it has been assigned now. And it's already over a minute, but still pending. So let's wait a bit longer and then we should have our IP address. It took almost 2 minutes, but now we have our IP address. So everything is great so far, but we got the IP address assigned dynamically. We couldn't select what IP address we want. In this case, it's fine, but sometimes you want to have full control over your IP addresses and everything that's going on. So now let's reapply the service, but define the IP address we want to have with the service. To do this, we have another file. This time we're going to apply the service internal IP YAML file. And while this file is being applied, let's take a look at this file. As you can see, there's this one additional line, and it is Azure Load Balancer IPv4. We can set the IP address we want. So this IP address is in the same range as the one we had before, but this time I can select exactly what IP I want. This again should take a couple seconds to change the IP address, but since we already have an internal load balancer, we don't have to recreate it. Now the IP address should be just updated. So let's check the service, and there we can see now we have the IP address we have configured before. So great. Now we have our service. We configured it to be only accessible from within the cluster or within the VNet. Now we have to test the access. So if I do a curl from my machine now, obviously it won't work because it's not available from the internet. So now let's create a VM that's inside the AKS VNet, and then we test the access from this VM. If you do this in the Azure portal, it's quite simple because you can just select the AKS VNet in the dropdown. But doing it in the portal is fine if you learn something new, if you want to try out something, but you should always have all your configuration as code. And so we're going to code it this time. It's a bit more complicated, but it also might be interesting to see what's everything involved. So the first thing we have to figure out is what is the resource group where all our AKS resources are in. When we create an AKS cluster, we define the resource group, but in this resource group is only the AKS instance itself, and all the resources of the AKS cluster, like the VMs, VNet, load balancer, and so on, are in a separate resource group. This resource group usually starts with MC underscore, but we can also script the access or the script to figure out what the name is. And to do this, we do AC AKS show, then we provide the resource group and name, and then we query the node resource group. This value contains the name of the resource group with all the components of the cluster. And if we print this variable, we can see what the name of the resource group is. So it always starts with MC underscore, then the resource group of the cluster, then underscore the name of the cluster, and underscore the location of the cluster. I was just hesitant for a second because I just saw that the name my resource group is probably not the best name for a resource group, but it's fine for now. Next up, we have to figure out what the ID of the subnet is that's being used, because we are assigning the VM to a subnet, not to the VNet itself. This is a little bit hacky, I have to admit, because I'm listing the VNet, I'm listing all the VNets inside this resource group. Then I select the first VNet I find, and then I select the first subnet I find and pick the ID of this. This works because I know there's only one VNet with one subnet. But if you have a resource group with multiple VNets, then this won't work. But for the demo, I didn't want to make it even more complicated. So let's just stick with this and get the ID of the subnet. So if we print this, we can see the full ID of the subnet, and the name is AKS Subnet. Next, to make it even more complicated, by default, the AKS VNet does not allow SSH access. This means if we add the VM to this VNet, we can't SSH into the VM because the VNet does not allow it. Therefore, we have to create a network security group and allow SSH. So first, we have to get the name of the network security group of the VNet. And again, this works because I'm querying all network security groups of the resource group and I pick the first one. This works because I only have one. But again, I want to keep it as simple as possible. In this case, the name is AKS agent pool, then an ID and NSG for network security group. With this, I can now create a new network security group rule, and this rule allows SSH in the VNet. So here I provide the name, the one I just queried, also the resource group I queried before. I give the name allow SSH, so I know what's doing. I set the port as 22, that's the SSH port, and the access is allow, so I can access the VM later over SSH. So that was quite complicated. As I said before, if you just want to try it out in the Azure portal, you can just select in the drop-down the VNet and then everything should work. But with this in place, we can now create our VNet, our VM, sorry. First, we're going to define a couple variables. That's the name for our VM, the name of the user and the password. Then we're going to create the VM. There's nothing special about it. It's an Ubuntu 24.04. And we are going to query the public IP address because we're going to need the public IP to SSH into the VM. So this should only take 1 or 2 minutes. And after this is done, we can test if our VM has access to the service in the AKS cluster. The VM is created. Now let's query the service one more time. So we remember the IP address. That's this IP address, the external IP. So I'm going to copy it and paste it on the side so I have it in the next step. And with this, we can now SSH into our VM. So we SSH with the admin user and the public IP address. Then we provide the password we created. And now we are connected to the VM. So now we should have access to our service. So let's do again a curl. And this time we use the public IP or the external IP of the service, the one we just copied. So if we execute this, we can see we have here the same message as before. Welcome to Nginx. Therefore, we know the access worked from the VM that is in the same VNet as our AKS cluster. In reality, you usually have several VNets and you don't want to have all the resources in one VNet. And in the next step, I'm going to show you how to create a private endpoint and how to add this private endpoint to a separate VNet. So let's exit the VM. Let's clean up this window. And to do this, we're going to create a new subnet, a new VNet, then a new subnet. Then we are going to deploy the VM into the subnet. And then we're going to create the private endpoint. So let's define a couple variables again. That's the name of the VNet, the name of the subnet, and the name of the second VM. Then we're going to create our VNet. The most interesting part is probably the IP address. Maybe you remember the AKS VNet had the IP address of 10.224, and here I'm using 192.168. I did this on purpose to show you that the private endpoint will get an IP address of this VNet. This means our private endpoint will also have a 192.168 IP address. So now we've created the VNet, the subnet, and now we can create the VM inside this VNet. So it's basically the same command as before. We're using Ubuntu 24.04, except here we're providing now the VNet and subnet name of the VNet we just created. And we also provide here the other name for the VM, so we can distinguish between the two of them. The VM is created, and now we can prepare our AKS service so we can create the private endpoint. Before we do this, we have to deploy or apply a new service file. This time we deploy the service Intel PLS YAML file. While this is being deployed, let's take a look at the file again. And as you can see here, there's again a new line. That's the Azure PLS create equals true. PLS stands for Private Link Service. And this is necessary if you want to access services that are running behind a load balancer over a private connection. Since AKS uses a load balancer for all the access, we have to create this private link service, and then we can use this private link service to create a private endpoint. And the private endpoint will be attached to the VNet. Now let's have a look. Our service, everything should be fine still, so all looks good. And to check that everything with the private link service worked, we can now query the private link service. So we're going to query it from the AKS resource group, and there we query the name and the alias. This should look something like this. So we have here the name, that's PLS, again for private link service, and an ID. And the alias is the same PLS and ID. Then I'm not sure what this ID is, might be the tenant. Then the location where it's running, and Azure.PrivateLinkService. So we didn't get an error message or anything, so everything is fine. Now we can query the ID of this PLS because we're going to need it for our private endpoint. This again, I list all the private link services in my resource group. I pick the first one and then I pick the ID. This works because I only have one. If I had multiple ones, then I would have to filter by the name. But again, to keep it as simple as possible, just pick the first one since there's only one. And if we print this, we can see we have our ID of the PLS. So with this in place, we can now create our private endpoint. So we provide the resource group, the VNet and subnet we want to attach it. So that's the VNet and subnet of the second VM we created. Then we provide a name. I use Nginx AKS service PE for private endpoint, so I know what this private endpoint does. Then we provide the ID of the private link service, and then we also provide a name of the connection from the private endpoint to the private link service. Let's create this. Creating the private endpoint should take around 2 minutes. And that's almost everything we need. The last step is we have to figure out what the IP address of our private endpoint is. If you remember, before we used the IP address of the service, but this does not work anymore because we are in a different VNet and we don't have access to the service directly. To get the IP address of the private endpoint, we have to query the network interface of the private endpoint. So you will use AC network private endpoint show. Then we provide the name of the endpoint we just created, the resource group. I just saw I forgot to use a variable here. I will update this before I upload the files. And then we query the first network interface, since you only have one, and grab the ID of it. If we take a look at this, we can see the ID of our network interface. And now we can just display the network interface and get the private IP address. So we use AC network NIC show, we provide the ID, and then we query the private IP address. As you can see, that's a 192.168 IP address. That's the IP from the second VNet. So it's completely different than from the VNet of the AKS. Now, with this IP in hand, we can test the connection. So we're going to SSH into the second VM that's running in the VNet that's not connected to the AKS cluster. Then we provide the password again. And now we can curl again. It's clear. We can curl the IP address, but this time we use the 192 IP address, which we just found out. If we query this, we can see we have here again our welcome page. It says welcome to Nginx, and this proves that we have access to the service of our AKS cluster over a private connection, even though we are in a different VNet. That's everything I wanted to show you. So today we created a new AKS cluster. We deployed an internal load balancer, which allowed us to access the service only from within the VNet of the AKS. We tested this with a VM, and afterwards we created a new VNet with a new VM. Then we created a private endpoint for our AKS service, attached the private endpoint to the separate VNet, and then we tested their access, and it also worked. I think that's a very great and powerful tool to keep all your resources private. This increases the security since you don't access it over the internet. It might also make the access faster since everything is going over a private connection that's managed by Microsoft. And overall, it should help you to build great software. With this, we're at the end of the video. I would really appreciate your feedback if you like this type of videos, or if they're maybe too complicated, too fast, if I should explain more, or if they're actually just how you like it. So let me know in the comments. And I would also appreciate a like, subscribe if you share the video. And with this, thanks for watching, and I see you next week with another video.